Okay, let's continue with the code itself. So first of all, I have my board connected, so I will show you how I usually work, how I use the script that I showed you before. So let's source the environment. Let's do the same in this one, in this window. So for example, I already showed you that I use the C to clean, B to build. I can connect to the board for the debugging purposes with the Seeger debugger and the GDB. So that would be, that was DBS for the server. Yep, waiting for the GDB connection and DB client to connect to it. Yeah, and that way we have the debugger connected, so we can do monitor reset, I think it was, yeah. And now break on the main. No? Okay, that didn't work. No symbol table is loaded. I guess I'm not passing the path to the proper binary, so it doesn't fetch the symbols. Let's see what might be wrong. So client GDB, blah blah blah. Oh, I'm passing the AXF, so I think it should be bin. Let's try again. So the server is still open. I connect here. No executable has been specified and target does not blah blah blah. So no, it's not correct. Okay. Let's then see if it's there. So file main bin. Yeah. It's just a binary. So let's see what I've got there. Oh, in the meantime, looking at the previous video, I know that I'm skipping a lot of things and it's not very clear what I'm doing, but this video isn't aimed at someone who doesn't know how to use Git or Git submodules, things like that, even though I sometimes don't know how to use it. But it's not a tutorial. Like, if you're interested in those things, you have to be able to Google a lot of stuff and see stuff for yourself, check stuff for yourself, be able to read the readmes of the SparkFun repository to install the requisites. I think you need to like actually do this for it to work, for the bootloader to work, because you need the py serial, so things like that. You have to figure it out by yourself. Like, I'm trying to go through the difficult parts and the easy parts are on you. Okay, let me see how I did it before, because I removed the scripts before, so let's see how that worked. GDB, blah 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 blah. Oh, did I use the AXF? No, that's the environment. And here I used the AXF. That's curious. Would that mean that I'm using the wrong path? Let's see. Project path. Okay, so if I do project path source bin main svl dot bin, is it there? No, there's something wrong in the path. Main svl dot bin cannot open. Okay, that exists. Main exists. Oh, it's ASP. So that would mean that I'm building the wrong binary, because it should be SVL. Curious. That's curious. Okay, I guess this session will be slightly about debugging this stuff, and in the process hopefully you'll learn something. So let's see, what am I building? Is it actually, yeah, ASB. So if you go into the makefile, ASB bin, that's what all does. Oh, I guess when I call the bootload, that calls this, and this one depends on the SVL binary. So should I change this? I could change that to SVL, and then calling just make on this file would go through this target directories, so that would be this, or and build the, instead of ASB it would build the SVL. Or should we do that? Yeah, I think that's what we're gonna do. Let's see how is it specified in the SparkFun examples. So if you go here and here, no, am I as always a bit lost? Is it examples? Artemis SVL, by the way. Oh, that's I think the SVL itself, the bootloader. So we can see the source of the bootloader here. Variable baud rate bootloader. Yeah, that's the bootloader itself. Okay, where was that? Okay, let me just find it like so. Common tools SFE. So it's boards, common tools, templates, makefile. Okay. How does it use the... Okay, so all points to the ASB. So it defaults to ASB. And you can directly call SVL, but that's the template one. As you can see, mine is a bit different. That might be because I have made my... let's compare them. So that's my... Let's open my makefile, and here let's open the template one. So here this part is different, as you can see. I might be using like an older version of this template. And let's see how SparkFun does it in their newest version, in the newest revision of their repository. Blah blah blah. No, I just want the GitHub. Yeah, here. Oh, that's taking a while. Oh, come on. Well, in the meantime, I'm just gonna change this to SVL. That's not a big of a deal. It actually should work. There's no reason for it to not work. Yes, save and exit. So now if I do B, that builds the SVL. Let me see, did I change that? This one? No, it uses the SVL. That's good. No, good. Yes, no. Let me check. Let me check because I don't know. Yeah, SVL bin, SVL IXF, and SVL bin. I need to figure out what those. Okay, let's figure out what those IXF files are. Also, IXF. Linker file, linking, blah 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 blah. Why are they there? Why are they necessary? I mean, they are not necessary. Like, does someone use them for anything? Or is it some like standard? Source bin IXF elf. It's just an elf file. Well, this is a binary file. Okay, Okay, I really can. Is it something that I can Google? And in the meantime, let's check their makefile. That's so slow. Come on. No, I guess why alpha and not AXF? Is the AXF like a Kale specific? Like Kale is an IDE, and I guess that might be specific for that IDE. Not sure, to be honest. What are the AXF files? Yeah, what are the AXF files? Okay, and in the meantime, tools SFE, let's see the template. So it's makefile template. If we go to the bottom, how is it right now? Oh, that's how it's used. Okay, so I guess I'm gonna adopt that. Like, I feel it's pretty nice way to do it. So let's go to the boards SFE common template, makefile template. Let's go to the bottom. Okay, so I'm using a Kakune as an editor, and it's pretty cool. As in, it has a server, and you can connect to it. So if you look on the right window on the right bottom side, you have client at 4626. So I can basically connect to that. And I can do source makefile, and that way those two windows are connected, so I can easily copy between them. So I can go here, I can copy this, I can go to another window, and I can replace this, and I can change that to SVL. Yes, is it okay? Is it good? Because normally when I call bootload, that calls boot follows SVL, that in turn calls the SVL target. So yeah, that should be good. Okay, so let's exit here, let's exit here, let's do C to clean, let's do, so now ls source bin, no such file or directory because bin directory has been removed while cleaning. So now let's build. That will create the bin directory, and that in that bin directory you will, yeah, see main SVL bin. So now if I do db server and db client, yeah, it says that reading symbols from. Good, we've got symbols back in. So now if I do monitor reset, be main, break on the main function, continue. Wow, I'm in the main function and I can step through the instructions. And on the right hand side you can see the server output of the J-Link server. So yeah, I can step through the code, which is very useful. Like, proper debugging is very important. I mean, you can go with printfs, which I oftentimes do, but debugging is important. Okay, so that's how I debug. That's part of it. Let's close those two. Let's go through the ITM. I wanted to show you the ITM. So that's actually debugging through printfs. So you can just start ITM. That's the command. Let's in the env. So ITM. Again, it just calls the J-Link SWO viewer. Yeah, and those parameters, all of them are important, like the CPU frequency and SWO frequency. Okay, so on the left hand side you can see the output of the ITM. So if I now press the reset button on the board, bam, you can see the output of the initially of the initting of the board. Like saying that word with braces is too difficult. Yeah. So you can see that first it turns off some peripherals because I don't want to waste energy on them. Why would I? Then it actually powers on the BLE controller, signals that the reset has been complete, and starts advertising. And so now if I take my phone, and I can see it on the list of devices. I press connect, pair, and now it has been pairing completed successfully, and now they're paired. So now I can basically, like pressing the buttons on that soldered keyboard of mine, I can start sending letters. And it works as a keyboard. And now if I, on my phone, if I press forget this device button, yeah, connection closed, advertising started, so it's advertising again as a device. I think there are some issues with it still, as in it's advertising, but reconnecting is something sometimes I think tricky, as in like I'm not necessarily sure it works properly, but it's a process and I'm not there yet. So okay, let's close this down then, and let's start going through the code. So one interesting source for you to learn more about it is there is a lot of examples in the repository, but they are hard to follow. And what I found to be an interesting example is the let me see where it is. Nope, I never remember what's where. Okay, I think it's here. Examples BLE. No, not here. No, I'm so sorry that I'm wasting your time looking for this, but I'm never gonna learn. Yeah, this one. BLE Geotag. So Geo. So Geo is the ARM Bluetooth stack. Yeah, I don't know if you pronounce it Geo. That's why I wrote it down, so you know. But you can put it in Google Geo ARM. Why did I, like, that's such a boomer thing to do. Why did I put Google in it? Like, just Geo ARM, that's enough. Okay, also, what are the AXF files? Object file format generated by RealView compiler. Also part of Kale's ARM MDK. Also, that's like Kale specific stuff. And Kale is like, is Kale paid? Is it like an IDE? I think it's an IDE for developing, yeah, Kale embedded development tools for ARM. Yeah, let's not go there. It's probably like some Eclipse monstrosity. Is it Eclipse based? Like from afar it looks. No, I don't. Is it? I don't want to know. Okay. So the ARM Geo, there is a lot of information here that is worth going through, but it's pretty high level, like high level as in it's not that easy to understand everything what's going on here, but still certainly worth going through it. Like DAB Wireless Software Foundation, there is like an OS here that's worth reading about, but it's very hard to actually understand it from this documentation. I think this documentation is kinda bad, or maybe I navigate, like, I don't know, maybe I'm not good at navigating it, but it's pretty bare bones. Okay, let's go to the Geotag example. So there is a lot of, like, the structure is here, the structure that's important, like you have to initialize the Exactal stack. Exactal stack is actually the Geo stack. I think the Ambiq guys, when they were doing that, like making the SDK, they still used the old name, Exactal. If you Google Exactal, you'll actually find that there was a company, yeah, I think that's this, temporary random. I found like a news, that might be this. A news that there was a company that created a Bluetooth stack and ARM basically bought them. Yeah. Vcentrix Exactal stack. So before it was an Exactal stack for Bluetooth low energy connectivity, blah blah blah. I think somewhere here it says that, no, I think here it just says that they won an award, but I think ARM probably just bought them, and that became an Geo stack. That became this basically. embedded Geotag. So still you can see like traces of the old naming. So here is the exactly. So yeah, what was I saying about the exactly stack? Yeah, anyway, let's go back to the examples. Yeah, I was showing you the examples of Geotag, because there is this exactl function, exactl stack init. Yeah, and that actually inits all the necessary things for this whole scope. It's big. It initializes all of the necessary things for the Bluetooth to work. I'm sorry that I'm spinning so much for this file. I'm gonna go slower, but I just want to show you this particular example because there's actually a lot of good information here that is very useful in implementing your own software. So here is actually the main function. There is a lot of things here in initialization phase. Yeah, good enough. And here it actually starts the application and then goes into a while loop. So that's what I want to go through, but I'm gonna go through it on my own application, because there's a lot of inspiration from that particular example, the tag example, but it required a bit of work for it to actually start and work. So yeah, that's the entire goal, to go through this file and explain to you why it's there and what's there. Let's start with the main function. So now we are in my application file. We're gonna start with the main function. I don't want this video to be longer than half an hour, so I might just abruptly cut it in the next 8 minutes, and then we can continue with the next one in the next part. So yeah, so as you can see, here is when the main function starts. First, we set the clock frequency to the maximum system clock. So this is like this typical board initialization stuff. It sets up the cache, which is nice. So I think I added this macro, no FPU, just because I wanted to turn off the FPU but leave those functions here if I need to turn on later, but I don't plan on making any computation stuff, so FPU probably like floating point unit, so that's for like accelerated operations on floating point variables. I don't need that probably. Here is the low power initialization, so I'm trying to leave myself comments because this platform is new to me, and so it's I just sometimes go into those functions, see what they do. So this one disables the xtal, so that's the 32K clock, uses this as a source for the RTC, this clock, low frequency RC, I don't remember. Turns off the RTC off. I don't like, that's not the important part, so you should go into it if you're interested in it, and I might go into it later if I need to do that. I'm not there yet. Okay, this actually pipes the printfs into ITM instead of UART. That's pretty convenient because let's go into this function. Oh, there's a lot of places where it's defined, but let's go to Artemis Thing Plus. At the bottom you can see all the list of the files where it's defined. So Artemis Thing Plus, BSP, AM BSP. Let's go here. So what it actually does is, it enables the ITM interface and inits the stdio printf to the ITM. You can also basically, there should be like UART printf, AM BSP UART printf enable. So you can like swap this for this one. If I go back to the main now, I could just like swap this to UART, and that would pipe it to UART, all the printfs. Okay, then I turn off the UART0, turn off the UART1. So that's basically, let's make it full screen. That's basically cutting off power from those peripherals like UART0, UART1, S card. I think it's SD card, like, I don't know, I don't remember. But that, again, I'm sorry, it's just not of importance right now. Like, yeah, I don't remember. Here is the list of like possible enums for that. Okay, not that important. And here you can see that it uses like the debug printf. I don't remember if there's like a, yeah, that's actually a macro, and that's if am debug printf is enabled. So I'm sorry, if you go to the makefile itself, am debug printf, yeah, that's a macro that's specified in defines in the makefile itself. So you can basically remove that, and that will remove the macros. Yeah, that will make the macros basically empty, which means that you can still have those functions there, those printf functions, but they won't do anything. So I could just basically delete this and compile without those messages. I think so. That would work properly. Okay. So here, unfortunately, we already start with the WSF. So WSF is the Wireless Software Foundation, and there is a operating system made by them that is very useful, like that the whole stack is based upon. And that's like the big part of what I'm gonna explain here, because it's not that complicated, but it's necessary to set it up correctly so everything works. So we're gonna come back to this one. Exactly stack init, that's a local function that sets up those exactly stack functions and objects that WSFOS uses. Unfortunately, like there's no convention yet. This one is like camel case. This one is that camel case and that snake case? I think so. Anyway, yeah. So I need to fix that because that's a mess. Because I copied the name of the function from the example and it stayed like that. I need to fix that. Start the scheduler timers. That's actually a very interesting one. So that's also a local function. Yep. So we're gonna come back to that in a second because that one is very important. That initializes the button arrays. So maybe we won't go like now. It's gonna be like high level overview. I don't have much time, so we're gonna come back to it. Okay, maybe just like few things. So AM devices is also an API that allows you to, here, yeah, AM devices buttons, for example. So there are some ideas of devices like buttons or LEDs here that are that give you access to, for example, in button cases, it's a debouncing, like it already implements debouncing method, which is nice, and like pressed and released buttons, which means that all of that typical boilerplate code that you have to write for handling buttons is already there, and you can use that. So that's the AM devices namespace for buttons. Yeah, and since I added some buttons, like those had to be modified. So I'm gonna show you that, I guess, in the next part, how to add buttons. And then again, that's WSFOS stuff. That's button handler, power cycle timer. So those are like OS specific stuff, and I'm gonna get into all of those. Here I just configure, that's AM HAL. So again, that's like the beginning is like the namespace. So if you go into the where is the HAL? The HAL part, is it here? Yeah, MCU Apollo3 HAL. Here you have like hardware abstraction layer, so we can set up GPIOs and things like that. And in this case is for the LED. And again now through the AM devices namespace. Namespace, it's not really a namespace because it's C, but you know what I mean. Hopefully you know what I mean. So that would be LED on. So that checks some things. Yeah. And in the end it just like resolves into AM HAL namespace functions. So nothing fancy there. Then it starts the HID application, and then there is the main loop, the while loop, where it updates the timers for the WSF OS, dispatches the OS tasks, sets the next wake up for the OS, because basically the board, yeah, here it sets the next wake up that basically uses a timer and goes to sleep, which is nice because that means that we're saving energy, like the OS goes to sleep here exactly. Yeah, and then when it goes out from sleeping, it turns off the printfs before it turns them off, then turns them on, then enables interrupts. So 2 additional functions that are of interest, and those I haven't looked much into. I just copied them, and I know that they're required for them to be there. But those are interrupt service routines. So those are what happens when an interrupt happens. And there are 2 of them, AMC timer ISR and AM BLE ISR. So those 2, let me see, common examples. Yeah, I think I just copied them. No, they're not here. AM BLE ISR, no, they are here, just higher, like at least one of them. AMC timer ISR, AMC timer ISR, yeah. So yeah, I just basically copied them. I looked into them a bit and left myself like few like comments for that, but not that much. What's interesting is that they are actually already defined, so without them, if you forget about them, it will also compile and work, because they're defined here in the startup GCC, if I remember correctly, but they should be here. Yeah, so those are like this ISR vector is a vector with functions that get called on specific interrupts. So you have a fine control when an interrupt happens, and here for example is AM BLE ISR, and yeah, and it's defined as extern, so it has to be defined somewhere else, I think. Oh no, not. Oh no, because it's a weak symbol. So which means that you can override it, but it also has an alias. So those are the attributes for that function. Alias is the AMBLE default ISR. So it should be here. Default. I can't type. Yeah, here it is. I might have modified this. Let me see. Did I can't really tell. Oh yeah, I did. Because like those lines like kind of stick out when it comes to the date compared to other ones. So I think I added those information because I was debugging and I wasn't sure what's going on. The board was crashing and it actually got stuck here, somewhere here. So I was printing that out for the ITM message. Where are those actually defined? Did I define it? I might have defined it. That's basically like a function that pushes character by character into ITM register. Nothing fancy. Okay, let's close that. Yeah, so those two symbols have to be overridden with those functions. We might go into them later, I'm not sure. Okay, it's getting long, 35 minutes. Next time we're gonna start in this file and go through it like line by line and with the WSF OS. There's a lot here to explain, so it won't be quick. Yeah, I think that's all. Thank you and hopefully see you in the next part.